Hey boys and girls, so today we're going to be going over lesson 6, which is area and perimeter of polygons in the coordinate plane. Just to give you a heads up, like we always do, if at any time you feel like you need to pause the video, please do so, especially if you want to try some on your own, and then you can always watch the video at the end. All right, so if we look at the do now, it says a quadrilateral has vertices with coordinates F, A, R, and T. And then it asks what type of quadrilateral is this. So just to get started, I had already graphed that just to save some time. Wait, oh my gosh. Are you guys seeing that? It's quadrilateral fart. F-A-R-T. Okay, moving on. So if it says what type of quadrilateral is this, if you think back to lesson 5, which was right before this, it gives you all of the strategies that you should use to determine what shape it is that you're looking at. So just by looking at the graph, it looks to me like it's going to be a trapezoid. So I just tested that theory by looking at slope to start. So on the side here, I'm just going to always be labeling my work. I'm going to write slope, and now I'm going to actually find the slope of all 4 segments. So I'm going to find FA first, then I'll do AR, then I'll do RT, and then to wrap it up, I'll do F to T. All right, so I just like to go right around FA, AR, RT, and then FT, just so I know I'm not overlapping or I'm not missing anything. I know that slope is rise over run, so how would I get from F to A? I'd have to rise 2 and then run 3. So I know my slope is 2 over 3, and it's positive because I'm running to the right. All right, next, AR. So again, AR, I have to rise 1 and then run 5 to the left. So it would be 1 over negative 5 because I ran to the left. RT, same thing, RT, I'd have to rise 4 and then run 6. So it's going to be a positive 4 over 6 because I'm running to the right. And I can simplify this. So if you have a graphing calculator at home, that's incredible. I actually don't. But if you do, you would have been able to type this in the calculator and it would have simplified it for you to be 2 over 3. And then last but not least, FT. So again, I'd have to rise 3, run 2 to the left. So that's going to be a 3 over negative 2 because I ran to the left. So now if I look back, I notice that both my slopes of FA and RT are matching. They're equal. So if I only have one pair of opposite sides that are parallel, like FA and RT, I'm just marking that on my diagram with those arrows to show that they're parallel. I know that that's the definition of a trapezoid. So you can always look back at lesson 5, but I have to say what type of quadrilateral it is, and then I have to justify my answer. So I could have just used the math and then wrote the word trapezoid to fully answer the question. But it's our first time talking about a trapezoid when it comes to like explaining, so I'm just going to write it all out. So I know it's a trapezoid because there's only one pair of opposite sides that are going to be parallel. And if they're parallel, I know from previous lessons that means they have what type of slope? You got it. That means they have the same slope. All right. Moving on to the guided practice. So again, a lot of these graphs, I just graphed some of it in advance just to save some time. So part A, it says graph the endpoints of one side of a regular pentagon. And then it gave me -1, 4, and 2, 3. So I know that this is graphing just one side of a pentagon. All of that's really important because does anybody know how many sides a pentagon has? You guys got it. It has 5 equal sides. All right. So I'm just graphing the 2 endpoints they gave me, and then I connected it in red here. Then part B tells me to sketch a right triangle. A right triangle is something we've gone over a lot in class, way before all of what's going on right now has happened. So you guys should know that you're just going to connect really our rise and our run here for our slope to make that right triangle. And then part C says using the Pythagorean theorem. So again, I know that the Pythagorean theorem is that a squared plus b squared equals c squared. So I want to use the Pythagorean theorem to solve for the length of the hypotenuse. So I know that the hypotenuse is across from the 90-degree angle. So when I'm drawing in those extra segments, I know the 90 is located right in this corner. So I'm just going to box that in there. And I know that the hypotenuse is across from the 90. So again, this has a length of 1 going straight up and down. This has a length of 3 going left to right. And I know that across from the 90, it's kind of tiny, so I can't really fit my arrow in, but across from the 90 is my C value, the hypotenuse. So now I'm just going to jump back over here and fill in. So I know that my legs are 1 and 3. Doesn't matter which one you put first. What does matter is when you're plugging in that you use parentheses. So when I add 1 squared plus 3 squared, it becomes 10. So I know 10 is C squared. And then how do I get rid of that exponent 2? By taking the square root. So if I square root both sides, I see that the square root of 10 is going to be my value for just C. So that's going to be the length of just the hypotenuse. And then part D says determine the perimeter. Perimeter is another really important key word. I'm sure most of you remember that. I'm just going to box it here and label that it means to add all the sides. So it's important that in part A, you had wrote down with me that a pentagon has 5 equal sides. So if this length is going to be the square root of 10, we can now add that to our diagram. If that's the square root of 10, I know that all 5 sides, if I drew it in, would all have the square root of 10. All right. So if I want to find the perimeter, I'm just going to rewrite it on the side here that a pentagon has 5 equal sides. So instead of me writing rad 10 plus rad 10 plus rad 10, right, 5 times, I could just say, well, I have 5 sides and I'm going to multiply them by the square root of 10 because that's how long each side is. And then that just becomes 5 rad 10. Okay, think of this almost like as a variable x. Like what's 5 times x? It's 5x. So what's 5 times rad 10? It's 5 rad 10. They're not both in the same form. This has a radical on it and this doesn't. So almost kind of think of them as unlike terms in a sense. You're not just going to multiply the 5 with the 10. All right, so at the end, I know that our perimeter, final answer, because it asked me to find the perimeter, is going to be 5 rad 10. And we are done with the guided practice. Okay, moving on to number 1. Okay. Okay, so it says graph and label the vertices of triangle PQR with those coordinates. So again, I just graphed it in advance, P, Q, and R. It's already on my graph there. So if we look at the next section, it says sketch a rectangle around the triangle so that the triangle is inscribed within the rectangle. Okay, there's a lot going on there. I hope that you guys aren't getting confused. Really, the only important word here is inscribed. Inscribed means like inside of. So if I want my triangle to be inside of a rectangle, I just highlighted my rectangle here in red. So again, I'm just making a rectangle right around that triangle because I want my triangle, the triangle to be inside of the rectangle. And right now my triangle is inside of the rectangle. So I'm just going to add that to our notes here. It means inside, and it's done. All right, now the last section says using Pythagorean theorem. Again, I'm going to go ahead and highlight that because it's telling me how I'm going to solve this question. So using Pythagorean theorem, I want to find all 3 triangles to, oh my gosh, I can't even read. Use Pythagorean theorem on all 3 right triangles to solve for the length of the hypotenuses. So whenever we're adding on those right triangles around, I know that this angle that's being formed is a right angle, same thing over here, and same thing over here. So I have 3 right triangles, so I'm gonna actually number them. I'm going to make this guy number 1. I'm going to make this guy number 2. And I'm going to make this guy number 3. All right. So if I want to find the length of the hypotenuse for all 3, like I always do, I want to organize my work here. So I'm just going to kind of label. This is going to be my work for triangle 1. And I know the Pythagorean theorem is a squared plus b squared equals c squared. And if I look here, I can see that this has a length of 5 and this has a length of 10. So I'm just going to add that to my picture here. This has a length of 5, this has a length of 10, and then again, it's that hypotenuse value, that C value that I'm looking for. So I know 10 and 5 are my A and B, and then C is what I'm solving for, the hypotenuse. It's across from the 90. So when I add these together, I get 125 equals C squared. And then again, I have to get rid of that exponent too. So instead of squaring, I'm going to square root it. So I know that the square root of 125 is going to be my hypotenuse. It's my C value for that first triangle, this segment right here. Now I'm going to do it again for triangle 2. A squared plus B squared equals C squared. And then again, if I add up my numbers here, those units, those boxes, this is 8 long and this is 6 long. So I'm going to add that, 8 and 6, and now I'm going to plug it in. So I know that 8 and 6 are my 2 legs. And again, C is the hypotenuse. It's what I'm solving for. When I add these together, I get 100. And then to get rid of the square, I'm going to take the square root. And this is a perfect square. It's the number 10. And then last but not least, triangle 3 in the corner. So now I have triangle 3. Again, we have A squared plus B squared equals C squared. This formula is not on the Regents. That's why we like you guys to rewrite it each time. It just helps you remember it. And then again, if I want to plug in, I have to see what the lengths are. So I can see that the bottom is 3. And I can see that the side here is going to be 4. Really, this is my height. So we have 3 and 4 as my legs. So 3 squared plus 4 squared equals C squared, the hypotenuse. When I add these together, I get 25. And again, I have to get rid of the square by taking the square root. And this is a perfect square as well. It's the number 5. So part C said using the Pythagorean theorem, solve for the length of the hypotenuses, and I did. We got the length of all 3. I'm just going to take a second to just highlight my answer here so I know that I have 5, 10, and the square root of 125 is my answers. Then if we look at part D, it says determine the perimeter. So we're seeing that key word again. I know that perimeter means to add all the sides. So it's asking me to add all the sides for triangle PQR. So we have PQR. Those 3 lengths we just found in part C because these line segments were the hypotenuses of triangle 1. It was the hypotenuse of triangle 2. It was the hypotenuse of triangle 3. So I just found the lengths of all 3 sides. So if I want to find the perimeter, I'm just going to add all 3 of them together. So I'm just going to rewrite it. So it's the square root of 125 plus 10 plus 5. Now I only have 2 like terms here, the 10 and the 5. So I'm going to put them together for 15. So now I get the square root of 125 plus 15. This would be my final answer in simplest radical form. Okay, if it said round to the nearest something, then I would actually find out what's the square root of 125, but it doesn't, so I'm going to keep it. Now part E says I want to find the area of each of the 3 right triangles. So I'm going to highlight that. Area is important. I know that if I want to find the area of a triangle, so if I want to find the area of, let's say, triangle 1, it's 1/2 base times height. Okay, another formula that needs to be memorized. I would rewrite it each time just to help you remember it. So if I look at triangle 1, well, triangle 1, I know that the height is perpendicular to the base. So I know that 10 and 5 have to be my height and my base, all right, because that's where the right angle is being formed. So 10 and 5 are the numbers I'm going to use for my height and my base. And then if I type this into my calculator, half of 10 times 5 is 25. And if I'm finding area, I know that it's squared. So I'm just going to write 25 units squared because it doesn't say if it's feet, inches, you know, anything like that. So here's my area for triangle 1. Now I'm going to do it again for triangle 2 and then triangle 3 after. So triangle 2 has a height and a base of 8 and 6. So I'm going to just plug that in using parentheses. Half of 8 times 6 is 24. So again, it's 24 units squared because I'm finding area. Area is always squared. And then last but not least, we have triangle 3, which again is 1/2 base times height. So the base in triangle 3, you know, is 3. The height is 4. It doesn't matter as long as you're using 3 and 4. And again, when I multiply that together, I get 6. And again, it's area, so it's 6 units squared. Okay. Part F is now asking me to determine the area of the rectangle. So part E was the area of the 3 right triangles. Part G is the area, but it's the area of that rectangle. The rectangle that we formed in red right back at the very beginning of the question. So how do I find the area of a rectangle? Well, I know that that's length times width. So if I look back, I can see that either 5 plus 3 is 8. So I know either the length is going to be 8, or I can look up at the top here because it already has the number 8. But either way, the length is going to be 8. And I can see that the width is going to be 10. So I can either use 10 on the left, or 6 plus 4 is 10 as well. And I know that opposite sides in a rectangle are equal, so I know top and bottom should be 8, left and right should be 10. So it's just another way to check if you've made any mistakes when you were counting those boxes as well. All right, 8 times 10 is 80. Again, I'm finding area, so it's 80 units squared. You guys are crushing it right now, about to be done. Now we're on G. So now it's asking me to determine the area of the triangle, so I'm going to highlight that. Now I'm finding the area of PQR, and I'm going to do that by subtracting the total area of the 3 triangles from the rectangle. Okay, so there's kind of a lot going on here. So I'm just going to write out what the question is asking me in word form first. So I'm going to find the area of triangle PQR. So I'm going to find the area of triangle PQR by subtracting. So I'm going to subtract the area of the 3 triangles from the rectangle. So I'm going to take the rectangle and I'm going to subtract it from the 3 triangles. So now that I have it written out in word form, I'm going to just plug in the numbers now. So I know that the area of the rectangle was 80. We just found that. And I know that the area of the 3 rectangles, well, the 3 triangles. So the 3 triangles were 25, 24, and 6. All right, so I'm going to put that all together, or I can just write them next to each other. So here we go. When I subtract the 25 and the 24 and the 6, I'm going to subtract all 3 of those from the 80. That's going to leave me with the area that I want. And that final number should have been 25. And again, I'm finding the area of this triangle, so it's units squared. And that would have been the final answer for J. Okay, so if we look back up top, it's as if I had colored in this whole rectangle, and then when I take away 1, 2, and 3, I'm just left with what I actually want, which is the triangle. All right, this was kind of a long method. It works every single time, no matter what shape it is you're trying to find the area for, but now we're gonna go over maybe a different method. All right, so now we're gonna just jump in to example 2, Again, I just graphed some stuff to start, so we'll jump in. Example 2 says, now we want to take that same triangle, so the triangle we just did in example 1, and we want to solve it with a different approach. Okay, so there's 2 different methods you can use to find the area of this triangle. Example 1 was kind of a long method, but it works every time. Example 2 is a shorter method, so we're going to go over that now. So if we look, part A says graph and label the vertices of PQR, which I already did, P, Q, and R. Part B is now asking me to find the slopes of PQ and QR. Okay, so I'm just going to highlight slope because I know that's an important vocab word, and I know that slope is rise over run. So I'm just going to write slope is rise over run. So if I want to find the slope of PQ, that's from P to Q, I have to rise, it looks like 6, and then I have to run 8. But I'm running to the left, so it's going to be 6 over -8. But I can simplify this, and again, if you had your calculator, it would have done it for you, but it simplifies to be -3 over 4. Okay, now we're going to find the slope of QR. So again, from Q to R. So I have to look like, it looks like I'm going to rise 4, and then I'm going to run 3. But I'm running 3 to the right, so it's going to be a +4 over 3. All right, I'm just going to highlight the slopes. They must be important because the question asked me to find them specifically. And now I'm going to kind of stop, and I just want you to look at them and see what you notice. So does it look like it's exactly the same? I feel like no. This is a negative. This is a positive, right? So off the bat, they're not going to be equal. But I do know that if this is negative and this is positive, and if this is 3 over 4 and this is 4 over 3, does it look like the slopes are going to be negative reciprocals of each other? Because I'm thinking that they do. So I'm going to say, yeah, they are negative reciprocals of each other. So yes, they are. And then it says that I have to explain what the slopes indicate about the line segments and about the triangle. So I know that if I have negative reciprocal slopes, it shows that the line segments, you got it, are going to be perpendicular. All right. And if those line segments are perpendicular, well, what do perpendicular lines form? Well, they form right angles. So I know that PQ and RQ are forming a 90-degree angle, right, at Q. So I added that 90-degree angle onto my picture after I found the slopes. So if I were you, I would add that to my diagram right now as well. So if I know that those line segments are perpendicular, then what does it mean the triangle has to be? Well, if the line segments are perpendicular, that means that they form right angles. That's how I know there's a 90-degree angle at Q. So what does that mean for the entire triangle? So this means that triangle PQR is a right triangle because it has that right angle. And we're getting all this information just from slope. All right, if we look at D, it says, how can this information help you solve for the area of triangle PQR? So we want to find the area of triangle PQR without using surrounding figures. So if you look back at example 1, when it says a surrounding figure, it means that we had to make that rectangle around that triangle before. Now it's asking me, how can I find the area without making a rectangle, without making a figure that's around that triangle? Well, if I know that this is a right angle, and I know that if I want to find the area of a triangle, I'm just going to write it down. Area is 1/2 base times height. In example 1, we had no idea what the base or the height were on this blue triangle. So we had to use that longer method a minute ago. Do I now know what the base and the height are in this right triangle? Absolutely, because I know that if this is where my 90-degree angle is, I know that heights and bases are perpendicular. So I know I just have to find the length of PQ and then the length of QR to find the area, and I'm done. Versus in example 1, we had to find the length of all 3 and then do a ton of extra work. All right, so how can this information help you? Well, now we know which segments are the height and the base. All right, so now we know which segments are the height and the base, so we can plug in and solve. All right, so if we look at part E, it says now we want to actually find the area of triangle PQR using this newer method. So if you look back at example 1, we had said this triangle that I formed in red here was triangle 2. And we had originally said this triangle in red that I'm forming here was triangle 3. So if I look back at triangle 2, because I already did the work, we had said that 8 squared plus 6 squared, right, equals c squared, which is this length that I need. But we already did the math. We said that it was going to be 10. So I know that the length of this segment is 10. Just 10. All right. And then we had gone back and we said, okay, well, triangle 3 is also, right, the work is on the last page. So if we do 3 squared plus 4 squared equals the hypotenuse. Again, the hypotenuse would be RQ, this length that I'm looking for here. We said that the math showed us that the answer was 5. So again, I'm just going to add that. I know that this is 5. So if I want to plug into my area formula, which is 1/2 base times height, if I find half of 5 times 10, I'm getting 25. And again, area, let me re-highlight that again. Area of a triangle is squared. So I know it's 25 units squared. And if you look back at example 1, it was the exact same answer that we got. All right, and then if we look at part F, it says, will this approach work for every single triangle? The answer is going to be no. It's only going to work if you know what segments are definitely going to be the height and the base. And I only knew that PQ and QR were the height and the base because these negative reciprocal slopes showed me that. I know that this had to be a 90-degree angle. So this approach is only going to work, it will only work for right triangles. Because I only know for sure what the height and the base are going to be if I know that there's a 90-degree angle there. Okay, and there's only right angles in right triangles. For any other type of shape, you would have to just use the first method in example 1 instead. All right. Oop. Oh my gosh, so sorry guys. This is so hard with the filming to make sure that everything is like there while I'm going over it. Okay, so here we go. Going on to the very last page, which has our example 3. Okay. Example 3 just says triangle RST is graphed on the set of axes, and I can see that it is. How many square units? I'm going to stop and highlight. If I have square units, the only thing that's squared is area. So it's really asking me to find the area, whether they gave me that vocab word or not. This tells me it's area. So how many square units are in the area of RST? All right. So if I want to find the area of this triangle, I'm going to start off by just writing the area of a triangle formula. So I know area is 1/2 base times height, and eventually I'm going to plug in whatever the base and the height are. All right, and that will give me my answer. Right now I have no idea what the base or the height is going to be. I don't see any right angles that form, the base and the height. I can't easily count the boxes anywhere. So now I have to think back to the 2 different methods that we just learned. I can either make some type of shape all the way around this triangle. That would be example 1. But that was kind of long. So I just drew in a little hint here. Always check the slopes first. So if I'm just eyeballing this, T is clearly acute. Okay, so there's no right angle at T. R also kind of looks acute to me. So I'm going to skip T and R right now, and I'm going to start with S. I think that there might be a right angle at S, and I could be wrong, I could be right, but I might as well test that theory. So if I want to check if there's a right angle, if I want to see if these lines are perpendicular, I have to first look at slope. All right, so I'm just going to label that slope. Always want to label your work. So I'm going to find the slope of ST, and then I'm going to find the slope of SR to check if there's a right angle. So again, I'm going to find the slope of ST, and then I'm going to find the slope of SR. Well, if I find the slope of ST, I can see that I have to rise 6, and then I have to run 12 to the left. So 6 over negative 12 is going to simplify to be 1 over negative 2. Then I'm going to go back for SR. Well, the slope of SR, it looks like I have to rise 6, and then I'm going to run 3. So 6 over 3, it was positive, and that's going to simplify to be 2 over 1. And now I'm just going to take a minute to highlight my slopes here that I just found. So I need those to be negative reciprocals if there's a right angle at S. And oh my gosh, negative, positive. 1 over 2, 2 over 1. So these 100% are going to be negative reciprocals, which is exactly what I needed. And since they are, I know that their 100% is going to be a right angle at S, so I'm going to add that to my picture right now. So if I know that S has the right angle, I know that ST has to be the height, and SR must be the base. So now I can use that shortcut method in example 2 to find the area. All right, so I'm going to go ahead and I'm just going to make a right triangle on SR, and then I'm going to make another right triangle on ST. Okay, and then I'm going to fill in my information here. I can see this has a height of 6 and a base of 3. And I can see this has a height of 6 and a base of 12. All right, I just counted that out in advance, so I know that those numbers are good. Now I'm going to go ahead and plug in. So I'm going to find the length of RS. I'm going to call this triangle 1 by using Pythagorean theorem. I'm going to take my 2 legs, plug in to find my hypotenuse. My hypotenuse is RS. So I have a squared plus b squared equals c squared. I know that 3 and 6 are the numbers that I want to plug in. When I add these together, 3 squared and 6 squared, I get 45 equals c squared. But again, I don't want that square, so I'm going to take the square root to get rid of it. So I know that the value of SR, which again was really my hypotenuse of triangle 1, is going to be the square root of 45. Okay, now I'm going to go back. I'm just going to draw a little line here. And then I'm going to draw a triangle 2. Okay, I'm going to label it. This is my triangle 2. I can see that my legs are 6 and 12. So I have my a squared plus b squared equals c squared. But again, I'm using 6 and 12 when I plug in. When I add 6 squared and 12 squared, I get 180. But again, I want to get rid of that exponent of 2. So instead of squaring, I'm square rooting. And again, I know that the hypotenuse of triangle 2 is ST. So the length of line segment ST is the square root of 180. And now I have my base and my height. So I'm going to plug it into my formula that I had wrote from the very beginning. So I have the square root of 45 and the square root of 180. Okay, Again, if you have the calculator on your phone, if you just turn your phone to the side, you have these options, the square root options. So you could try to type this in and get your answer without just relying on the video, just for practice. If you don't have a phone or if you don't have a calculator, I'm just going to tell you, when you type this in all at one time, using parentheses with the square root, you get a final answer of just 45. So it turns out that the answer was actually just choice 3, which was the square root of 45. All right, you guys are killing it. Please make sure you continue to turn in all of your work. We look forward to seeing it. All right, have a nice day.